Hi, everybody. While he's pulling that up, oh, here it goes. Here it goes. My name is Josh Dotson. I'm the Industry 4.0 leader for Koch Inc. Can't say Koch Industries anymore. I've actually only been in this role for about a month now. I spent 10 years in one of the operating companies within Koch before that. So here to talk a little bit about how we think about industrial data fabrics and why we think they're important and where we're going with them. So real quick, an overview of Koch holistically, if you're not familiar. We are made up of 8 operating companies, global operating companies, 120 to 130 billion dollars in revenue every year, 130,000 employees across 60 countries. So it's a very large company. So in my last version of this, I had animations to walk through each one, but y'all get to see the whole picture before. So wanted to talk a little bit about this mental model and how we're thinking about the way we do work now versus what the future looks like with industrial namespaces. Sorry, not industrial namespaces, industrial data fabrics. So on the left, if you're an operating company, it doesn't matter what capability you're in, what type of role you do. That's kind of how we're working right now, right? So if you're a reliability engineer, an operator, or something like that, and you need to go solve a problem, what do you have to do? You've got to go to all your different data systems, right? Grab your documents, grab your historian data, grab your work order data, consume that manually as a human in order to gain some actionable insight, right? And if you think about it, this same mental model applies regardless of what type of capability you're doing in a business, right? You can put an HR professional in that same spot and they're doing the same thing. They're going to the HR systems, they're going to, I don't know what systems HR goes to, but they're doing the same thing to generate some kind of insight, right? You can put a finance professional in there and they're going to their financial data, they're going to the market data. So the mental model is applicable, and that's how we do work, really just across the business, right? If you think about an operating company long-term, over the long term, all the variability that applies within that space, all the different people that are coming in, trying to do the same thing, they all bring their opinions and their biases, right? The problems and the solutions are never the same because it's a manual analysis every time, right? I'm sure everybody is dealing with the same, turnover rates that we are at Koch. You're trying to train somebody to come solve problems, do the same job, and you're always going to end up with a different solution, a different insight, right? Also, training somebody in this kind of space on the left, right? You bring in somebody, their very first job is to try to figure out which way's up. Then their next job is, here's all the systems you have to go to find the information that you need. Here's all the people you have to go talk to solve the problems on a day-to-day basis, right? So it's not a very sustainable or optimized solution, right? So on the right side, that's kind of the way we're thinking about what the future looks like. So sticking to the industrial space, you've got all this data coming in from all the various systems. You've got data pipelines that are all coming into a knowledge graph, a knowledge brain, and it's all contextualized, right? Now, in this space, you don't have to rely on each individual going to each system. They've got kind of a one-stop shop, right? That's kind of the end goal. Once you have that, the industrial data fabric or the knowledge graph, you can then start building your applications on top. You can start building solutions on top or putting people in touch immediately with the data that they're looking for, right? This also gets really, really powerful in the age of AI, because if you think about what AI needs to return a good answer, it needs a whole bunch of additional context that's specific to your data, right? So building AI solutions on a knowledge graph is super, super powerful. Whereas if you're trying to build an AI, solution on the left side, where you are going to end up with siloed data no matter what. A very specific use case using AI, right? So the data fabric is kind of the precursor, a prerequisite to having actual value or getting actual value out of your AI agents, right? So one of the ways we're thinking about the future in smart manufacturing, right? Because that's what this is. We're trying to get to a smarter manufacturing space. There's this maturity model. This is a colleague of mine's. And there's really 4 phases. The first is standardization and stabilization. If you try to apply a connected knowledge graph to chaos, you're going to end up with chaos, right? We all hear about dirty data. Poor data in, poor data out, right? The next phase there is, now that you've standardized, stabilized across your systems, across your data, across your processes, now we can start building that digital fabric. Your outcome is the data fabric or an industrial knowledge graph, right? Once you do that, then you can start getting into, he calls it ubiquitous augmentation, but really what it means is all the data is available for all the people when they need it, right? The outcome of that is connected workforce. Who has heard, yes, we've done connected worker before, right? And when you look at it, I see some heads nodding, but when you look at it, all it really was putting a digital tool in the hands of somebody. Well, it's because they bypassed that second phase, the digital foundation, and went straight to, all right, we're going to put an application in somebody's hand, solve one problem with one siloed solution. If you skip the digital foundation, that's all you're ever going to get. You really need the digital foundation, the digital fabric, and the knowledge graph to get to a point where everybody has all the data they need when they need it, right? The 4th phase there is, once you've started to identify patterns of behavior, you're asking the same questions repeatedly and getting the same types of answers. Now you can start to automate that knowledge using the knowledge graph, right? Automation also applies to robotics and things like that, but I'm talking about automation of knowledge here. So the next thing I kind of want to talk about is some of the barriers to good data quality coming in, right? So I contend that the easiest data to keep clean, feeding into your knowledge graph, is like IoT data, right? Your instruments, the things that are very, very automated. What's really hard is, oh, there it goes, is the human knowledge coming into your knowledge graph. So think back to the mental model and the variability on the left side where you've got a new employee coming in, but you're still reliant on them to put data into a system. I don't think there's any systems out there that don't have a human putting information into it, right? But if you're relying on training for every single new employee, you are just constantly pumping energy into that situation, and it's not sustainable long term, right? So we have to solve that problem somehow. And I know it's not like an easy solution or an easy problem to solve. But I think there's a couple things that help. If you're not familiar with the human action model, it's one of my favorite mental models. So essentially what it says is, in order for a human to take action, 3 things must be present: a sense of unease with the current state, a vision of a better state, and a realistic path to get there, right? What I've seen is that a lot of people coming in, they don't really have a vision of a better state. So if you're relying on them to put good data into a system and they don't know why they're doing it, they don't care. They're not uncomfortable. They don't have a vision of a better state, right? So bringing a compelling vision, showing them how they're impacting everything else downstream really, really goes a long way. A good example of this, in Case, where I was for 10 years, we went on this journey, and one of the things we did is we were putting in a connected data platform, and we said, all right, across the board, we're going to connect our 4 core data platforms and make it available for everybody, right? Not every plant was using all 4 of those platforms. And so what happened is the ones that didn't have all the platforms in place couldn't get the results, and immediately they started saying, oh, we want that. Here's the path that we need to take to get that. And it really drove a sense of urgency. So we provided a compelling vision of what a better state looks like with this, industrial data fabric, and it really did drive action, right? If you think about a lot of the roles we have, so I keep talking about people putting in data. One of the examples of this is, so we use a maintenance management system, right? Like a work order management system. We are reliant on our gatekeepers to, as a work order comes in, we're reliant on our gatekeepers to understand the context of that work order and then properly code it and put it into the rest of the system, right? That variability, there's variability across not only that own gatekeeper over time, but across all the different gatekeepers. And so what we end up with is bad data so that we can't use that downstream. We can't calculate our MTBFs using our work order data because it's so inconsistent, so dirty over time, right? I don't know that human action solves that problem because at the end of the day, that's a competency problem. So the other approach that I think is important for us to think about is using technology to enable consistency over time, right? So we did this experiment where we were using generative AI and rules on the back end and said, basically what we did is we talked to all the gatekeepers and said, okay, tell me what your definition of corrective maintenance is and reactive maintenance and predictive maintenance. Took all that in a transcript, said, okay, I'm gonna put that into AI and say, okay, AI, this is how we think about these types of things. And then we will feed it a work order and say, okay, take these definitions and code the work order. And it was remarkably accurate, right? It drives consistency over time if you can take the tacit knowledge out of people's heads, put it into a system, and then use that system over time, right? So I think that's just one example of using technology to drive consistency in the data input process into your knowledge graph, because dirty data, bad results. So this is just a quick stat. I won't go into this too much, but that top right box, there is a significant drop in the amount of employees in the industrial space and how long they're staying in a role. So if you don't think that your role turning over or your organization turning over roles is a problem yet, it's coming. It's coming. People just aren't staying in jobs for the same amount of time. So we really have to figure this problem out. Last thing here is just kind of an example of what we're thinking about in terms of a connected workforce solution that is enabled by an industrial data fabric, right? At the end of the day, what we're shooting for is the right data to the right people at the right time. But we've got different personas doing different roles across the organization. So the data that they need, the format that they need it in is different, right? So that's the way we're thinking about it, some of the things that we think are coming and why we think it's important. That's all I got. Thank you.